Thanks for joining us here at BP Learning. Today we're putting together another one of our kits. This is the tone generator kit. Before you put this kit together, you should already have put together the electronics basics kit and gone through that video. It's actually best if you go through both the how to build it video as well as the technical details video. In this video, we're going to be doing the tone generator, and we're going to learn how to make a simple tone using electronic components. Now, we have a few components that are required from your basics kit, which you should know how to work. Start out with your breadboard, and the breadboard is how we keep components together. It's how we attach them together. It prevents us from having to solder wires or anything like that. It will connect our components together. And just as a quick refresher, the way that a breadboard works is that each half row contains a wire behind it, so that any two holes that have a wire in them, those wires will be connected together inside. Okay? And so these half rows are connected together. And then additionally, these are known as power rails, and these have wires all the way down them. And the purpose of these is so that you can connect your positive voltage source and your negative voltage source to these rails and supply it, so that anytime you need power, you just need to hook a wire up to one of these rails. Okay. So the second thing that we're going to attach to this is our power module. Okay. So this is what allows us to power our device. And so this plugs in. Notice it's got these legs over here, and the legs line up. They also have a plus and a minus symbol. See if you can see that. The plus and the minus symbol on each of these, and those need to line up with the plus and the minus on the breadboard. So if they don't, you need to flip it around. So there it lines up. So we'll put these so you can see those fit into the holes, and we fasten it on. Make a good solid connection. Okay? And so what we'll be powering this with is our 9-volt battery. Now the clip connector comes with your starter kit, but the battery itself you'll have to supply on your own. So when we plug this in, it turns on, and we have a little on-off switch we can use to turn our project on and off. So when this is on, that means that these rails have power applied to them, positive and negative. Okay. So we'll turn this off while we're building it. And so here is our schematic that we'll be building to. And so what this will do is, here is our headphone output. Let me show you the headphone output jack. Here's the jack, and we'll plug our headphones in there. And on the back side are the connector pins. And I don't know how well you can see those. There's 5 connector pins. There's 1 up here, and that's for ground, and then 4 back here. And the ones that we use are the outside pins. Okay, the inside pins are for different purposes than we'll be doing in our program. But if you're just sending output to headphones, use the outer pins and then connect that middle pin to ground. So this is a 555 timer chip, and it's called an integrated circuit. And the reason they called it that is because this package has a whole lot of circuitry inside it. Now it's very, very tiny. It's packed full of little teeny tiny transistors. But they're packaged in such a way that it'll fit on the breadboard, and you can access the main access points through these legs. Now, to know what each leg does, you have to know what their number is first. And so you see there's a little notch at the head of the chip. See that little notch up there? So that notch tells you where pin 1 is, because pin 1 is always right to the left of that notch. And then the pins are numbered 1, 2, 3, 4, and they come around 5, 6, 7, 8. So those are your pins. And we're going to go ahead and put this in the breadboard. I'm going to orient it so that my notch is toward the top. So I'm going to get all of my pins lined up on both sides. Oh, look. Sometimes these come a little bit wider than your breadboard, so you have to just squeeze the pins a little bit to get them to line up. So you squeeze the pins, and once they line up right, it just slides right in. Okay? And because these are only connected in half rows, there's not a connection going across the bridge. Each of these half rows are all connected, so that means that anything that we put in these half rows will be connected to the corresponding pin of the chip. That's how that works. So the timer chip is an interesting chip. What it does is it basically has some circuits that allow it to store up charge to a certain point, and once it gets to a certain threshold, it discharges that charge. And on each cycle, it also has an output. And the output will go on and off depending on whether it is filling or discharging. Okay, so here's what the chip looks like. Pin 1 is ground. Okay, pin 8 is our positive voltage. Okay, pin 3 is our output. Pin 4 is a reset, which we're not going to actually use. And notice how there's a line over it. Anytime there's an output or a pin with a line over it, that means that the opposite signal than you'd normally think of is used to set this. So for example, this reset pin, we would normally give it a voltage, and when we want to reset it, we take a voltage away. And since we're never going to use the reset on this, we'll just tie this directly to our voltage source so that it will never reset. Control is used for stability. This discharge is used for draining, and our two detection points are threshold and trigger. And what these will do, so basically what's going to happen is we're going to have a circuit that is going to fill a capacitor. And a capacitor is like a tiny battery, which we'll see in a minute. And the circuit will fill the capacitor, and when the capacitor is 2/3 full, this chip will cause it to start draining the capacitor. And when the capacitor is drained down to 1/3, it will start filling again. So it'll continually be going up and down, filling and discharging this capacitor. And the output will either be high or low, depending on whether it is filling or discharging the capacitor. So what is a capacitor? Well, capacitors come in a variety of shapes and sizes. This is known as a ceramic disc capacitor. So this is a ceramic disc capacitor. And what it does, it is basically a very, very tiny battery. And when I mean tiny battery, I mean it will hold a charge for fractions of a second. It is super teeny tiny. And this is a 100 nanofarad capacitor. Okay, so it stores a very, very tiny amount of charge. But we don't need it to store very much charge. All we need to do is fill it and unfill it. And so this chip will measure whether or not our capacitor is 2/3 full down to 1/3 full. Okay. So another type of capacitor is an electrolytic capacitor. Now our so it's kind of barrel shaped. The ceramic disc capacitor doesn't have a positive or negative side. Both sides are the same. But on an electrolytic capacitor, they do have sides. And so those are, you can tell the side because, first of all, the positive leg is longer, just like in our LED. And then the negative leg also oftentimes has a little stripe on the case. Okay, and these are actually hold a lot more charge than these little ones. We will use these capacitors for doing a couple different things. One of which is maintaining. The chip uses these capacitors to help it keep a current flowing, and then we'll also use them to couple our audio output. So we'll talk about that as we go along. We also have, just like we had in our old kit, we have resistors, and we have two different values of resistors. We have two resistors that are 10,000 ohms, and we have one resistor that is 100 ohms. And then we have, we're going to have two of these electrolytic capacitors. These two resistors will control the speed at which this capacitor is filled and discharged. This resistor will control the volume at which the signal comes out. One of these capacitors, they're both the same value, they're both 10 microfarads. One of these we will use to keep the power stable to our integrated circuit, and the other one we will use to send audio out to our headphones. Now, headphones are not included with this. You can use whatever headphones you wish, but you can plug them into our jack here. So the first thing that we're going to do on this is we're going to connect in our resistors. Okay. So I'm going to turn this around a little bit because if you look in the instructions, I want this to be oriented the same way as our instructions. So the instructions that come with the kit have it oriented this way. So the first thing we're going to do is we're going to take a resistor and we're going to put it into the power strip, positive power, and we're going to wire it onto the board. Right about there. Now remember, it doesn't matter exactly where you put this on the board. The most important thing is that the things that are lined up in the picture, if they are on the same row, they have to be on the same row in here. If they're off by one, it's not connected. Okay? So they have to be on the same row. Okay, so see, these two resistors are connected on the same row, and also this wire. So that means that whatever row you put these in, they all have to be on the same row. And you should always go back and check yourself to make sure that you did that right. So then we'll have a second resistor that comes from that same row and comes over a bit. And the current is actually going to go through both of these resistors to fill our capacitor. Now the resistors, it doesn't matter which way you put them in, and the ceramic disc capacitor, it doesn't matter which way you put it in. Now this capacitor is going to plug into the same row as that final resistor, and the other leg is going to go into the negative. It's going to look like that. See if we can get a good angle on that. So those two are in the same row, and these two up here are also in the same row. All right. So now that we have that in, that's how the capacitor is going to fill up. Now it's going to discharge only through this capacitor. And so we're going to have a wire that goes from that resistor to the discharge point on our chip. Okay. So that is how, once it fills up, it's going to discharge back out through this pathway. Okay. Now, it has to sense how charged it is. And it actually has two sensors for that. One detects when it's a third full, and one detects when it's a third empty. Okay. So we'll do one right here. That will, so both of these are right on the same row as the capacitor. And this one will go into right there. And this one will go into right there. All right. So this one detects when it's a high, when it's 2/3 full, and this one detects when it goes down to 1/3 full. Okay. So that will control. So this chip handles this capacitor filling and unfilling, filling and unfilling, filling and unfilling, over and over and over again. Now, so what does it do? What good does all this filling do? Filling and unfilling. Well, it uses the amount of time that it takes to control the output. And the output comes out of this pin number 3 right there. So we'll put a wire right into pin 3, and we'll just put him out somewhere on the board that we'll use later. So that's where our output's going to go. This orange wire will be our output. Okay. Now, the chip itself needs a positive connection. So this pin 8 goes to positive. Okay. And then pin 1 goes to ground. Over here we have pin 1, and we will connect it to ground, and that will power our chip. Okay. So the next thing we need to do is add in, this is known as the control capacitor, and we will put it in right about there. And all this does, you could actually go without this capacitor, but its goal is to keep the power level in the chip at a constant level. And we will put a wire from that to the control pin on the chip. All right. So now, what we need to do is we need to, remember we talked about the reset pin, that's normally positive. So we just need to tie this reset pin to positive power. All right. So now we need to know what to do with the output. Now the output of this chip is either positive or it's 0. Okay, so it'll swing back and forth between positive and 0. And that swinging back and forth really fast is what will make your headphones make a sound. Now, the problem though is that headphones don't really like you to swing between 0 and some number, they'd much rather swing back and forth all the way across 0 to negative, all right? And so when you have something that doesn't swing all the way back and forth across 0 volts, that just kind of hits bottom somewhere above 0 volts, that's called having a DC offset. And so if we want to, we can use a capacitor, though, to couple together our AC and our DC offset and our AC circuits. And so that's what this capacitor will do. Now the positive side without the stripe needs to be over here and the negative side's over here. That's on this capacitor, the positive side goes to the board and the negative side goes into the negative rail. Okay, so that brings our output. You can see those two are in the same row. So that couples our, this is called a DC bias because it doesn't swing all the way across 0. And the other pin of this will be basically the same voltages, but it will swing across 0. Okay. And then we need a resistor. And the only thing the resistor does, you could actually go without the resistor, but what the resistor will do, you could replace it with a wire, but the resistor will limit the output sound of your, it will limit the output of your, try that again. Sometimes when these circuits start getting full, it's a little hard to put everything in. So that will limit how loud the output is. Okay. So then what we need is we need our trusty headphone jack. And this side of the resistor will go in the same hole as our jack. Now the jack needs to be all the way on the board because this ground pin is actually going to go onto the board. So we're going to put it in like that. Okay, and so notice that this resistor, let's see if we can see that well, this resistor actually goes in to the left of the this jack. Okay, and then we're going to add a wire so that we have both left and right sound. Going to add a wire that goes from the left side to the right side. And then the middle is ground. The middle, you can then just take to ground over here. And that is our completed circuit. Okay, so just kind of show you how this goes. So the output is coming out of this orange wire here. Okay, and the output will go up and it'll go down, and it'll go up and it'll go down, and it'll go up and it'll go down. And the vibrations of that will cause your headphones to vibrate and generate the sound. Okay, so how does this chip know when to go up and when to go down? Well, it does it based on how full this ceramic capacitor is. When the ceramic capacitor is 2/3 full, while the ceramic capacitor is filling up, it turns on the output. When the ceramic capacitor gets 2/3 full, it switches off the output and starts draining the capacitor. And when the capacitor is 1/3 full, it turns the output back on and starts filling the capacitor again. And it does this by switching on and off this discharge pin, which is pin 7. It's this blue wire here, and it's connected to pin 7 of our chip. Okay, and so when that discharges, so when this detects the level of this capacitor is 2/3 full, it will cause this discharge pin to go to ground, and then current will come out of the capacitor to the ground and until it's 1/3 full, at which case the discharge will switch off and it will start filling in again. Okay, So let's get out a pair of headphones. And as I said, headphones don't come with this, but you can use whatever pair of headphones you have. So plug in a pair of headphones and turn it on, and you will hear, I don't know if you can hear this, but you can get this close. Oh, disconnect. So, and you can hear the noise generated by the speaker. Now, the actual tone can be modified based on these resistors. These resistors control the speed. The size of the resistors control how fast this capacitor is charged and discharged. And if you have bigger resistors, it will take a longer amount of time to charge and discharge this, and not give you a lower sound. Because it will mean that the total period of going up and down is longer, and so the sound will be lower. And if you make these smaller resistors, they will be higher. You can then adjust the volume with that resistor. If you have a bigger resistor, you have lower volume. So that's how to build the tone generator. And if you would like to know some of the mathematics behind it, and some of the more intimate details, you can watch the technical video on it. Thank you for watching.